These are the beginning notes for Chapter 10, Gases. Most of this chapter should be a review from Chemistry 1 with a few new formulas thrown in. We're going to go ahead and start with the basics. So you can see he starts off the notes with a picture of a gas, lots of space in between, and they're moving. Usually when you see a diagram, a particle diagram of a gas, the arrows, the length of them is going to represent how fast they're moving, just so that you can start to interpret them correctly, especially if one gas changes, maybe temperature, maybe volume, maybe pressure. You can interpret how this speed or kinetic energy would be affected. So the kinetic molecular theory has a few postulates. We're going to go through them one by one. So the first one is gases contain a large number of molecules and they're in continuous random motion. So not only are they constantly moving, but the movement is random. They're going to hit another gas particle or maybe a wall of a container and move in a different direction. Most of the volume of a gas is going to be empty space, so you can see in this diagram up here, most of this gas is just this white empty space. There's only a few actual gas particles. Okay. The pressure of a gas comes from a force exerted by the particles when they hit the container wall. So if this particle were to hit this top wall, it would exert a force on this wall, which creates pressure. And so that force arises from the change in momentum that occurs when the particle hits the wall and changes direction. So you can see in this diagram up here, he's showing you the particle hits the wall and exerts a pressure. The pressure is force over area. Okay, so down here, we're going to have to be able to read lots of Maxwell-Boltzmann distribution charts. This is supposed to represent a monatomic gas. Monatomic